Saad, I think your mic is muted.
Thank you. Can you hear me okay now?
Yeah.
Okay, cool. So the idea of normalization over here is that you pretty much take your tables through a process of refining it. In this process, generally, you will go up to third normal form. Very rarely, you will go to the fourth normal form. Normalization is where an entity relationship diagram would be taken to a level where every table will have one and only one primary key with no data redundancy and all fields dependent only on the primary key. And that's basically the three normal forms. So the whole idea of a normal form is summarized in this one table that we went over in the chapter 3. The reason I'm reviewing it so that I could record this as part of the recording available for the course that I'm going to make available afterwards. And also before I put you guys in the breakout rooms to solve problems, once again, you have seen it at least once more. So first normal form is where the data is organized in a two-dimensional table. However, all of the items in the first normal form should be such that no row should have more than one values. So everything should be dependent on a primary key. A primary key could be one or more fields. In that case, it's a composite key. Usually what happens sometimes when students are solving these problems, they jump directly to a third normal form, looking at the problem statement, and in that they may miss out on some details. That's why in some of these problems, you will see a breakdown that I want you to first take it in the first normal form, and then from there, take it to the second normal form where we try to remove partial dependencies. For example, if there is a field that is partially dependent, for example, in our case, the warehouse information was dependent on warehouse and the product information was dependent on product. So we took it out from the first normal form table into two separate tables and put them in their own respective tables. And then in the third normal form, we start to look at, okay, there is a field called city and state, which are dependent on zip code. And the zip code is dependent on the warehouse address, warehouse ID. So we took the city and state out because they were dependent on a non-key field in a separate table. And that's how we linked the two together. So on the Blackboard, under the course documents, under normalization, you have normalization exercises. There are 3 exercises. Each one of them is a Word document. You click it and it opens up like this. Okay, so here is currently the form. So this is the unnormalized form. What is it? And then what will be the first normal form for this data set and the second normal form? And you got to decide if it needs to go to the third normal form or not, or if you're able to solve it. Because sometimes that also happens that we stop at second normal form because the data is normalized. There isn't anything to be done for third normal form because there isn't any transitive dependency, which is a field dependent on a non-key field. So like that, you will solve that. You know, last time we did this, you guys were not able to do a screen share and I had to come in and do that individual, like in each of the groups. So let me try this. Let me turn on this feature right here. And maybe if I do this and then send you a breakout in breakout rooms, then things will be different. So let me pause the recording here. I'm going to start it again when we go into chapter 4. Recording. Oh, my bad. Okay, so then you talk about the descriptive text for the column, reference to the name of a standard column data type, default column headings, column data type, length, default values. So all of this is being part of the chapter 4, where we talk about converting the design into, like the non-physical or logical design into the actual physical design. Okay, so moving on to some of the concepts here. For object ownership, a common practice at many companies is to have single user profile that owns all the objects. And then you can specify authorities to whoever needs access to different objects. So that's one thing. Well, at this point, you need to be able to figure out what data types you'll be using, the max and the mins of the data types. Two more difficult exceptional cases are not applicable in unknown. Now, for example, you'll notice that when you're filling out a form, there is an option of n/a. So how to tackle that? The first arises when a column might not always have a sensible value, such as a column of a part that has no particular color. The second case is different in that a value for the column might make sense. It just is not known what the value is at some particular point in time. So you need to come up with some default values and things like that, so that there is always some kind of a value to go in. Then you need to be able to figure out the primary keys from the candidate keys, and some of the candidate keys may turn into unique keys. For example, you have social security number, the social security number, and also you have your student ID number. They're both considered to be what? Candidate keys, out of which one, which is student ID, will be promoted to your primary key. The social security will remain a unique key. Now, can unique keys can be null?
A unique key? No.
Means a key that will force you to not have a duplicate in the field. However, you cannot use it to establish relationship with another table. That's called a unique key. Cannot be used as a relationship key, but must hold unique values. Can such a field also have a null value? What do you guys think?
Well, if it's got to be unique, I'd say no.
The unique key has the special feature. Whatever values are there must be unique. So it's quite possible for you to have a null value. That's one of the reasons that the candidate keys, when promoted to primary keys, sometimes we will drop some unique key from some candidates keys, because at some point in time, they could possibly have a, what you may call it, null value. For example, social security number, right? Social security number can be null. Why? Because everybody that enters US doesn't have a social security number yet. So some people may be coming to colleges, taking classes, but they don't have a social security number. They may be exchange students, foreign students. For them, social security will be null, but whoever has it will be unique. So that's the candidate key. And then you can always have the foreign keys also there, so that you can establish relationship. Specify view implementation. What is a view? A view is like your logical files, where you have a table fields, one or more table fields extracted into a view, so that you can give this view outside of the organization or within the organization to somebody who doesn't have access to the entire data set, but only some data that is related to their job. So you can have your views in place. Of course, you need to specify security implementation. That's DBA stuff. So you probably, a common developer may not be doing that stuff. So the grant statement, which is called the GRT-OBJAUT, grant object authority command, then can be used for that purpose. Then if your table will be queried on fields other than the primary key very often, then you may want to index those additional fields, because primary key fields are automatically indexed. Other fields are not automatically indexed. So index is like index of the book. So it makes things easier for you to find. So for example, if I have a books table, books are very rarely searched by ISBN number, even though ISBN number uniquely identifies them. Books are more commonly searched by titles. So that's why you would want to promote the title to be an index field, even though it's not a primary key field. So that's another thing to work on, the indexing. Hierarchy of data. Computer languages provide the computer with instructions to perform specific tasks, and that's where the data comes in, where you have a raw material, which when it starts making sense, it becomes information, where you retrieve it, and you understand what is a variable from programming, that it's a memory location, which is name, that can be accessed from the programmers. And when you start working with the SQLPL, which is the stored procedural language of SQL for DB2 UDB, that's where you will see variables. But SQL, in its true sense, does not have variables. Database tables, rows, and columns. Well, something that you guys are already familiar with, like what is a table? It's a collection of information structured in rows and columns, also called file, where a record, which is a collection of data placed in the columns, and the column is a single field. So that stuff he's talking about, dividing it to bytes and stuff like that. I will not going to be going into some of the details. Let me tell you, okay, this where he talked about bytes and internal mechanism, the ASCII keys and abscisic keys. Moving on to page 15 of the PDF, which is about data types. Now that's important stuff. Every database vendor may have their own proprietary data types, maybe one or two, but generically speaking, most SQL databases will have similar data types, like character for fixed length, varchar for varying length. Differences, they both have a maximum size. Character will always take the full size, variable character within the maximum will take however much is needed. So anything that is fixed length and will always be fixed length, such as phone number, social security, those are character fields, good candidates. Variable character for things like name, addresses, city, state, that kind of stuff. Then we have decimal that has the size and the number of decimal places within that size. And the range of the size is 1 through 31. Small int, which is a fixed size, 2 byte, negative 32,000 to positive 32,000. It is equivalent to short data type in Java and C#. And integer is equivalent to an int data type in Java and C#. And big int is equivalent to long data type in Java and C#. Then we have date, which is typically in ISO format. That's why the author shows you the ISO format date here. Year first, hyphen month, hyphen date. And then Boolean, which is true, false. These are the data types. And then he goes over the character type, the decimal types, and the integer type, and just explains each one of them. Okay, here we have a sample data from a table. So we have a list of fields. Each has a data type. Now, some data types don't have a size. Why? Because they're fixed length, like integer, small int,
Yep.
date, okay? But they do occupy bytes, but same fixed amount of bytes. So that's why he is basically telling you that this one record structure will take 69 bytes of allocation. So it's telling you in bytes. This is first 4, the next 2, and the next 19, and the next 20, and then goes like that. Okay, let me go down. Okay, here we come to the actual SQL. Hold on a second. Okay. So we'll talk a little bit about this part, and we will continue some of this next week because I was just checking the syllabus. The chapter 4 and 5 will continue next week. So we'll do maybe a couple more pages of 4 here. So SQL is a structured query language. You can call it SQL, or if you are in Alan's class, you can call it
SQL.
SQL, right? So SQL is a language which allows you to communicate with the underlying database engine. The SQL commands are not categorized in different categories, but only for the understanding purpose. So the author on this page talks about two main categories, which is DDL and DML. DDL commands are data definition language commands, which pretty much tell you the commands that are for defining objects or working with objects, such as create command, such as delete, drop command, such as alter command. Those are the three definition language commands: create, drop, and alter. Data manipulation language commands work with the data, so such as inserting data, updating data, deleting data, selecting data. That's part of the DML command. So those are the two main commands. Then he goes into the running environments. In order for you to write your SQL, that's like starting next week, we will be logging into the V2 cloud and we'll be working with the run SQL scripts. Some of the stuff that we will be doing, I believe you guys did this last semester in advanced Java when we started to go into creating tables and inserting and updating them. However, there are a few things that we did not go over, so we'll be looking at that those details, and in table creation and table alter commands. I don't think that we looked at table alter commands last semester. And I don't know, in Alan's IBM and .NET, do you guys interact from the SQL server? Oh, sorry, from the Visual Studio? Or you write any SQL, or you use the built-in tools?
For
IBM and
.NET,
.NET. Yeah,
kind of a mix of both.
mix of both. Okay.
Mostly just C# though.
Okay.
We did run things occasionally, but mostly just the C#.
Okay. Okay, no problem. So anyway, so run SQL script allows you to write SQL commands, and then you can work from there. And one of the common things that we know is that you can always use the green screen 5250 emulator, which has a SQL utility that you can start by typing str_sql, and it starts up the SQL utility, and you can use that utility to enter the commands as well. So you can do it that way. Also in the RDI, it gives you access to the query by example, where you can insert data that way as well. But however you want to interact with the database object, the objects must be placed inside a schema. Schema is like user profile. You can create a schema if you don't have one, but all of you are provided with a schema to start with. So you create your schema with a schema name. And then once the schema is created, you can then start setting the schema to that schema, whatever schema you want to be in your user profile to be your schema. And then you can start creating tables within that schema. Okay, so we'll stop here for now. And I want you to rather, let's do this. Let's go a little bit into it, and let's get to see if we can actually also log into the V2 cloud, because we still have like 20 some minutes. So let's do that. How about you guys log into V2 cloud? Okay, is everybody in? So once everybody is in, you can click on ACS, which is Access Client Solutions icon. And in the ACS, does everybody has under system debtstar.gtc.edu listed under the system?
Yeah.
How about Jose and Oscar? Okay.
Give me 1 minute. I'm logging in right now.
Okay,
I believe
okay,
I
sure.
have it. But let me
Yeah,
check.
sure.
I'll let you know.
Sure. Yeah. We'll wait till, because that's an important step.
Okay, I am in ACS now.
Okay.
And
So do you see under system debtstar.gtc.edu next to the system drop-down box at the top?
okay, then.
Let me know if you don't, then I will show you how you can.
No, when I clicked on the drop down box, it says select system. Select
Okay.
a system.
Okay. So then let's do a configuration then. If you look down under management, do you see system configurations as one of the options?
Yes.
Okay. So double click on that option and then click new button. When the new button is clicked, you will see an interface like this. In the system name, type debtstar.gtc.edu. Okay. And then you click OK.
Okay.
And then you can click close here.
Uh-huh.
And now try in the drop-down box if you can see DebtStar.
Okay.
Do you see it?
Yes.
Okay, choose that.
Uh-huh.
And now everybody, all of you click on Run SQL Scripts. It will ask you to log into your IBM account. And then it will be connected. I'll tell you that it's connected. Okay, is everybody with me so far?
Mm-hmm.
Okay. Now, let's go back to the chapter itself. When you want to create a table, you write the command create table followed by the name of a table. Name of the schema is not required. Then you start a parentheses, and you may end a parentheses with a semicolon, and between the two parentheses, you start listing your fields. So your field name followed by a data type, followed by maybe not null constraint if you do not want that particular field to have a constraint, to have a null value. And then when you're done listing all the fields, you put a comma after the last field only to promote one of the listed fields to a primary key status. You don't have to do this, but this is one of the three approaches. So let's look at the first approach today, that how you can create a table and promote one of the fields to the primary key status. Okay, so that's what this shows. So now let's say if we go back to this environment, and if you want to have a larger font size, you can do that under View Font, and then you can choose whatever font size you want to see. I think it goes as high as 36. So create table. And just 1 second. Okay, let me create a table call Bet 2022, right? And then so we're going to have a pet ID, character 4, not null. And then we can have a pet name, variable character 20, not null. And then we can say primary key, and let's promote pet ID to the primary key status. Simple, to the point, short, small table. And whenever you're done writing this code, for those of you who remember it, you know how to run it. For those of you who do not, or seeing it for the first time, you know, you can select this and you can click on the last hourglass symbol, which is run selected. It will run it for you and will tell you that it ran successfully. The table got created. Okay. Anybody has any questions? So we create comments with like this, with 2 hyphens, we have comments, okay? So let's say if I ask you to create a table called invoice with the following fields: invoice number, character, size 4, invoice date of type date, and invoice number as primary key. Okay, let's see if you can do this yourself. Model this one after the one that you wrote just right above. Let's call it invoice 2022 to have. Oops, reconnect.
All right, that worked.
Okay, so we have invoice number. Invoice date. And then we have a primary key of invoice number. So if you notice, they are modeled very, very close to each other. Everybody got that too?
Yep.
Okay, let's move on after the create command. Run SQL script. We'll come back to other constraints, but we look at one constraint this far, which was not null constraint, and the other one was primary key constraint. It goes into comments. We looked at that. Default values, we'll look at it next week. I want to quickly go on to no, I don't think so. It's in this chapter. But anyway, I will introduce that to you right here. We will come back to some of these topics next week as we still need to work with chapter number 4. So let's introduce a foreign key primary key relationship here. So we will create a table called invoice pet 2022. So we'll have a, okay. So in this table, we want to have a field called invoice underscore number, same field description. We want to have it as a primary key, and we will also going to have it as a foreign key. So this is a second way of creating a primary key, that you can list the word primary key in the same line where you're doing your description. Similarly, let me grab the pet ID and also make that a primary key. So I have a composite primary key here. Okay. Then let me have a procedure, which will be variable character, size 40, not null. And we'll have amount decimal, let's say 7,2, not null. Okay. So these are the fields that we have created. Now we'll start establishing the foreign key relationship. Okay. So we'll say constraint foreign key INV 2022. For constraint name, constraint type, the local field, which is invoice underscore number, references our table, which is invoice under 2022, where the primary key is invoice underscore number. So basically we are saying is I'm creating a constraint. This is the name of the constraint. This is the type of the constraint. This is the field, local field that I'm promoting to the foreign key status. And the primary key is found at the and so place. So we'll do exactly the same thing with pet ID, because we have multiple keys here. And let's run it. Oh, hold on a second. Did I miss anything? Why is it complaining about it here?
Invoice 2022 doesn't have a pet ID thing on. Did you change that? Did I miss that?
Pet underscore ID pet 2022. Oh, my bad. I didn't change the name of the table. Okay, so I'm gonna run it now. Still complaining about that. Okay. Pet underscore ID character 4. Pet underscore ID character 4. Keyword clause starting with primary key not valid. Okay, let's see if I do it like this. Primary key pet underscore ID.
I think it might be because procedure is a keyword.
Oh, you're right. Maybe let's try changing that name to a different one before we do that. Okay, let's do that. No.
No.
Let's see. Nope. Oh, still complaining about primary key for some reason. Remove all but one specification for each keyword or clause. Hold on a second. Okay, so. Okay, let's do this. I think DB2 allows you to do that if you do something like this. Invoice underscore number. It only allows you to list it once. Here you go. You cannot list the constrained primary key to constraint twice.
Mine did not work.
And also I changed my procedure to procedures. And I dropped primary key from both of the lines.
Oh, oops. Never mind. It would work. I just.
Okay.
Mine is giving an error on the first constraint.
Oh, did you put a comma there at the end of primary key?
Oh, thank you. Sorry.
Mm-hmm.
So the primary key can be up to 3, 4, 5 fields.
Yeah, there is no limit. Yeah, there is no limit, but yeah, but you got to list them all in one place.
In one place.
Yeah.
Okay, that works.
Okay, now go to the Blackboard and look at assignment number 2. So I've given you an entity relationship diagram that needs to be converted into actual physical tables, from physical design to physical tables. And the plus sign means it's a primary key, and then hashtag means it's a foreign key. you always create, which of the two tables will you create first?
I think device would be created first. Or no.
Device category will be created first
Yeah.
because the foreign key table will require the primary key table to already exist. And even though the ER diagram has the field BLOB for description, so that's note number 2 for the description and detail fields, using BLOB fields in the design, but you will use varchar 300 and varchar 500 respectively. You don't need to add any data. It's just create this relationship of primary key and foreign key relationship here using the example that we did in class. Where'd that go? And this script that you just wrote, you can also save this script by simply clicking File and Save. And then you can choose, on this PC, for example, and if I want to save it to my desktop, week 2 SQL and get saved so that, you can refer back to it later on. Otherwise, as soon as you close it, it will be deleted. Okay, guys, that's all for today. You just need to work on the assignment outside of the class.